Let me summarize what have I been doing with Archimedes' method of solving for the perimeter of the circle, which is the circumference. So what he did is to inscribe and circumscribe a circle with different polygons. So we could say you could start with it using a triangle. Yeah, so he inscribed it with a triangle, and he also circumscribed it with a triangle. There you go. There you go. Oops. There you go. So here he reckoned that, of course, in this instance, the perimeter of the circle is is greater than the smaller triangle, but less than that of the bigger triangle. And what he did is what we always call the method of exhaustion. And essentially, you increase the sides of the polygon. So in here, we could increase it to something like more of a square. So let's say increasing it with putting a square inside and outside. So let's say I'm going to put this down here. There. So obviously the perimeter of the square is closer to the perimeter of the circle than that of a triangle. And by doing that, he also enclosed the square, the whole thing with so that's inscribing a square and circumscribing it with also a square. So this is really what the method is all about. So of course the drawing is not that accurate if you're done freehand. You can try it yourself. So here it's very confusing, but the perimeter of the square here, yeah, is closer to the perimeter of the circle. And so is the perimeter of the square, bigger square, also perimeter of the circle. So by increasing the number of sides, you get close to the circumference, the value of the circumference. And here you keep on going and going about it. So let's try what we call inscribe it more with something much more closer to the circle. And so we can say, what about a six-sided figure? So we can also do that. A six-sided figure. Let me just think how to do this. It's tricky. Okay, here it is. It's going to be one side. This is the second, third, fourth, and fifth, and then the sixth. So you see here, yeah, that's inscribing it with a hexagon. And of course, you also have to put a hexagon outside, and that's always so tricky. So we could just say, we could do 1, 2, 3, 4, 5, and 6. It's a little bit messy, but you can see that the more sides you are, the more close you or the perimeter of both the inner polygon and the outside is closer to the perimeter of the circle. And this method of increasing sides is really what Archimedes did. And So although we're only doing this an example, you can think about it. We tried it with a triangle, yeah, inner and outside the circle. We tried it with the square, and then we tried it out with the hexagon, both inward and outside the circle. So here is a method of exhaustion that we've talked about, and the more sides you have, uh, the easier it is. So essentially, you know what? Ultimately, Archimedes went on to have a 12-sided figure, and then he doubled this to the 24th, and then 48th, until he reached a figure that has 96 sides. And this 96 sides looks like really close to the circle. So this is called the method of exhaustion. And we're going to try out moving from 6 to 12 sides, right? And we'll see what will happen after that. So this is just to summarize what we have been doing in the past few days. Before I proceed in calculating a polygon with 6 sides to 12, just as Archimedes did, I'd like to say something about the perimeter of each polygon, because I've solved some of this in the past. We know in our first example of Archimedes' style of calculating pi that the perimeter of this square is really, the inner square is around 2.84. That was one of our calculations. And here, the perimeter of this hexagon in this unit circle is essentially 3. So let's just say this is the perimeter of a square, a four-sided figure. This is the perimeter of a six-sided figure, which is 3. And I'll talk more about that later on. And the perimeter of an eight-sided figure, which is an octagon here, and I did solve that in my last video. The perimeter of that is close to 3.12. And you can see it here. Yeah, that's increasingly close, getting close to the value of 3.14. Now, what do you think would be the perimeter of a 12-sided figure? So this is, to be exact, this is really around 3.1 something something. Yes. And then once it reached to the 12-sided figure, which is really, this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait a minute. 1, 2, 3, 4, 5, 6. So should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So, 12-sided figure, it is still 3.11. Yeah. And with a decimal. Yes. So it's getting more accurate as we go through. Now, Archimedes went on to solve for the perimeter of the 24-sided figure, the perimeter of a 48-sided figure, and the perimeter of a 96-sided figure. Yes. Now, I'm going to show you a book. And this book is really a value of pi. So that's the book. Yeah. A book of pi. This whole book. Yes. Let me just put this in here. This whole book is the value of pi. Yes. So there you go. And we're only solving the first few digits, but look at that. See? Look at those. I'm skipping quite a lot. So this is a book of pi. And this is how many pages long? 314 pages long. See? There you go. 314 pages long. And how many sides is this? Well, this could be around, this could probably have more than, yeah, more than 100,000 sides. Yes, more than 100,000 sides. So four-sided figure, look, within a unit circle, the value is in the accuracy is increasing. And think about this. This is a one number. This is the value of pi. So this is the modern equivalent now, and we'll talk more about what's the importance of calculating to that number. And now people in different universities are still competing who has the most digits of pi. So that's all that I wanted to say.